Hi, so this is a machine learning project where we will be building a model for prediction of types of cards a bank might sell or try to sell to its customers. So let's move forward and see what all it includes. First, let's understand what we are trying to do here. So we have a dataset that contains information about people that are using cards issued by a particular bank. Now I won't name the bank, but from its data, it states out some of the characteristics of these people, which includes family information, maybe marital status, and how often and in what way they are using the bank issued cards. Now, we will be using this dataset to predict the type of card a customer may issue. Details of the project. Now, this project is actually divided into three parts. So the first part is building a machine learning model to predict the type of card a customer may issue. Second, we have we build a web application model or a web application on the framework Django and predict and use the prediction model to mount on this Django project or application. Third, we deploy the Django project on Heroku through GitHub. So the first part. So we start off with building a machine learning model and we use a random forest classifier model and train that model using the bank card data points. There is abundant information on how cards are being used by the people, but you might have to search some complex terms which constitutes as columns in the dataset before you may start preprocessing the data. Now the dataset in particular has a lot of columns where the ratio for how much the card is being used and on what basis the card is being used, how much the customer is paying for that, and if he or she wants to renew the card or maybe upgrade. So all of that type of information is present, but again you might have to look up some of the terms before you understand what that column signifies in the data. So next we have Django web app. So this is the second part of the project where we will be building a web application using the Django framework. We mount the model we built in the previous part on the Django project here. And this is the last part, that is where we deploy our Django application on Heroku using the connections to GitHub. So now let's start off with the first part, that was building a machine learning model. Hi, so this is the first part where we will be building a machine learning model to predict the type of card a customer may issue or a bank might try to sell. So first, here you can see the first code block is to mount the drive folder onto this collab notebook, meaning now we can actually access the files stored in our drive folders from this collab notebook. And the reason that I have done this is because later on I'm going to access my bank customer CSV file from my drive folder itself. Now the second block here you can see is stating that it is importing necessary libraries. Now these are not the list of all the libraries that I'm going to use, but the list of libraries that are going to help me in maybe data manipulation or understanding more about the data or so. So first you can see that the first library present is the NumPy. Now it is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can also be performed easily and efficiently. And this is just an alias that I am using, that wherever I'm trying to use the NumPy library, I'm going to type np and it shall denote that I'm trying to import some of the functions from this NumPy library. Next is pandas. So it is a library for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. So you can see that there's a huge table here present, right? And it has a lot of columns here. So to demonstrate that and maybe manipulate data inside this table, pandas is used. Well, next you can see that there are two libraries, Seaborn and Matplotlib. Now, while Seaborn is a library for making statistical graphics in Python, similar to Matplotlib, Seaborn actually helps in exploration of your data in a much more visualizing manner. Now, both of these libraries are actually present for visualizing your data to understand more from your data by plotting graphs. There are different kinds of graphs like pie chart, histogram, line graph, box plots, and so. But Seaborn is much better at visualizing as compared to Matplotlib. Now the next thing you can see is that again I'm using the pandas library and calling the function read CSV. So it takes on the path of a CSV file and it stores it into a variable. Now bank variable has all the values present inside this CSV file. And using the head function, taking the parameter 5, it is showing me the first 5 entries in the CSV. And you can now see that the first 5 data points are present and all of the columns. And as I told you in the introduction also, you can see that there is a column for total amount change in Q4 to Q1. Now these are quartiles of the year, and again total change, credit change in Q4 to Q1. So you have to look this up before going forward. Though for very important columns, I do have given a brief of what they are, like for average utilization ratio or maybe credit limit or some of the other columns. But if you specifically want to look them up, and I don't have actually given you any of the information of them, then I believe that it is better that you look them up from Google or from someone who works in a bank, but don't just blindly dive first into the data set only. So next thing you can see that there's a shape function that I'm calling, and it is giving me the number of rows and number of columns. So now there are 21 columns and 10,000, more than 10,000 rows or data points. So I've just specified what we are trying to predict. So what we are predicting is card category that the customer is going to go for, or the bank might try to sell someone. And that category is here, card category. So it has blue, platinum, gold, silver, right? Now I'm using the function isNull and dot sum. So isNull is a function that actually gives you true or false regarding if a column has a null value present in it or not. And sum is basically a summation over all the null values, all the number of null values present in each of the columns. So as you can see, there is no column present that has a null value. So in respect to null values, this dataset is pretty clean. So this is a brief, you can read it or maybe skip this part, right? So first I'm trying to understand a little more about this data set. And this here you can see is a box plot using the Seaborn library only. So this is to set the theme as the name suggests, and white grid is basically this background having only summations and requirements for 30, 40, 50, 60, 70, which is giving the numbers or averaged values inside the customer age column actually. So what does this box plot imply? Now, this box plot is trying to tell you that most of the values present are actually between 40 to 53, 54, 54 maybe, right? And the 50th percentile or the median value is present this line depicting the median or mean value here, actually the mean value. And this box tells you that most of the values are actually present inside this box only, which ranges from 40 to 53, 54. And this dot or these dots actually tell you that there are some outliers present. Outliers meaning that these are extreme values which are categorized as extreme in regard to the rest of the values which are present in this box, right? So maybe age of 70 and 74, 75 is considered to be an outlier value. So as there are very less outliers, we can say that the customer age is actually a decent column and will not maybe derail the model when we are training it using this data or this column, right? Next, we are using a special function, that is group by. Now group by is a very distinctive function because with the help of that you can take on a column as a measure for other columns. Now this might not have been a very good explanation for what group by does, but let me just show you the example, right? So I've taken two columns that are gender and credit limit, right? Then I've used the function group by and taking the parameter as gender column. Then there's another function that is aggregate, and it is giving me the mean and count. So basically taking gender as my basis or gender column as my basis, I'm trying to find the mean and the count for the credit limit, right? So you can see that for the gender female, there's only two genders, right? Male and female for this data set. So for female, the mean of credit limit is 5,000 and for male it's 12,600. And the count is meaning the number of females present inside this data set is 5,358 and male is 4,769. So you can see that there's a very strange number. For females, the credit limit is very less as compared to the males. Now, there would be many of you who might not be understanding what credit limit is, and that was one reason why I told you to look up these terms before you actually move forward, right? Because these terms are not really the basis of what I'm trying to teach here, which was building a machine learning model. Now, next, again, I'm using the group by function, which is again taking the gender as the basis and again taking the mean and count, and you can see the average utilization ratio for a female is 0.34 and for a male is 0.199 or 0.2 to round it off. So I've given the brief of what average utilization ratio is. So it's how much you currently owe divided by your credit limit. It is generally expressed as a percent, right? But here you can see the actual ratio only. For example, if you have a total of $10,000 in credit available on two credit cards and a balance of 5,000 on one, your credit utilization ratio is 50%. You're using half of the total credit you have available. So with that in mind, you can understand what these ratios mean. And for females, it is pretty high as compared to males. Another thing to ponder about. So next I'm using the group by again, but this time the column is card category. So before moving forward, let me tell you that group by also creates a similar structure to data frame, but here the data is accumulated in a way that it revolves around the column that you have provided. Now here you can see that I've used the function max on the customer age, right? So max function is giving me the max value for customer age. But if you would have used this max on customer age on the bank data frame, then you might have gotten a different kind of result as compared to here, because as I told you, now this bank cards structure revolves totally around the categories inside the card category. And now just using directly the max function, I can see that for the blue category, 73 is the highest age, for gold 63, for platinum 56, for silver 65. Now in terms of expensive and luxurious, platinum is the highest, then gold, then silver and blue. So it's like a little distorted as to how blue has the highest age for the customer age category, while a 56 is the highest for the platinum one. Next, you can see that again on the bank cards group by structure, we have the customer age and minimum, and you can see that the platinum has a minimum of 39. So yeah, you might have to work a lot to get this platinum one, right? And next is the columns. So basically I am depicting all the columns that are present inside the bank dataset or my bank cards dataset, right? Next, again, what I'm trying to do is find the mean for average utilization ratios for each and every card, type of card, right? And you can see that for blue, the ratio is much higher as compared to all the others, with platinum having the least. Next, I'm using the group by function for marital status, right? So now this bank marital structure will revolve around the marital status only. And now you can see that for divorced, all the categories has this many numbers of occurrence. For married, that means in simplistic terms, if a person is divorced and he or she has a blue card, then there were 696 number of people which categorized as divorced having blue cards. There are 46 people who categorized as someone who has a silver card and is divorced. Similarly for married, single and unknown. Unknown being their marital status is not exactly known or is not depicted in the form they might have filled when filling up their details in the bank, right? So you can see that the trend is actually similar in all of the marital status. Blue having the most number of people, silver, then gold and platinum. Likewise for married, single and unknown. Right. So next is finding out categorical data in our data set. And for this, we are going to move on to the separate video, that is the next video, where we are going to understand more about the categorical data, how to pre-process them, and finally building our machine learning model and training it. So this is the second part where we will be now understanding what categorical data is, how to pre-process them, and use them for training our model. So here, as you can see, the first column that I am taking is the iteration flag. Now I'm using the function value counts, which basically tells that how many unique values are present inside that column and how many times each unique value occurred in that column. So you can see that there is only two unique columns, one being existing customer and the other is iterated customer. And the number of times each has occurred inside this column is also present, that is 8,500 times and 1627 times. Now, what do you mean by iterated customers? So this basically means that the customer has now left the services or has stopped the services for the card from the bank, and the existing ones mean that they are still ongoing with the services, right? So here there are two things that you can do. First, that you can remove the attracted customers values from the data set, right, to only keep the existing customers and then train your model, or keep both of them and then train your model. So this is your choice, right? And you might be able to see some differences maybe in prediction, right? But for now, I have taken both of them and then trained my model. Next, you can see the gender. Again, this is most probably will always be a categorical data consisting of male, female, and maybe some other genders. For this data set, it only had male and female. Next, you can see the education level. Again, education has 1, 2, 3, 4, 5, 6, 7. Total 7 categories present inside it, and number of time each of them has occurred inside that column. Similarly for marital status, right? So from this point on, we are now trying to change or process the categorical data into numerical data, which can then be fed into the model. So first I'm trying to change the gender, not change the gender, right? The gender column, right? I'm turning it from a character value to a integer value. Now, so I've created a function that takes in a value x, and if x is a character m, then it returns 1 or else 0. Then I'm used the function map here, right? So map takes in as a parameter another function which it then starts to put on each and every value inside the column. So what happens is that there's a column gender. It has a lot of values present inside it, and map takes in the function ref1 and starts to apply that function on each and every of the values present inside that gender column. So there's the, let's say there's this gender column, then the first value, let's say that is an m. So this function works on that m, understands that there's a m present, then it replaces that m with a 1. Then in the second column, sorry, in the second row for the gender column, it understands that the value present is f, that is a female. So it takes in the value f and sees that it doesn't satisfy the if function. So return a 0 here. So the f is then returned or replaced by a 0. Similarly, for attrition flag, that is another column which was a categorical column. If the X represented an existing customer, return it by 1 or else by 0. Next, what I'm doing is converting the categorical data into numerical data, but for the card category. Because again, card category is a string value, right? Blue, gold, silver. So I'm trying to convert that into the different numerical value, that is 1, 2, 3, 4 maybe. And before doing that, actually, what I'm doing is taking a copy of bank. So this copy function actually copies the whole data which is present inside bank and shifts that to X. So now I have two variables which have exactly all the values present inside my original CSV, right? But the main thing to understand is that if I make any changes in X, it won't reciprocate into the bank, right? These are two different entities now. So using x.head, I can again look at the first 3 data points inside my data set. So you can also see that income type is also a categorical data which is specified by less than 40k, 40 to 60k, 80 to 120k, 60 to 80k, unknown, which means that they haven't provided the income, and then 120k plus, right? So all of these are actually in dollars. Next, you can see that I am importing label encoder. Now label encoder is the like easiest and most efficient library to use if you want to convert your categorical data into numerical data. So I have now defined a function which takes in a value which is actually a column from the data set. Then first it calls out the class, that is label encoder, then uses the function fit, then uses the function transform. So it fits on the data, then transforms the data, meaning here the string values are now shifted or replaced by the numerical values that the label encoder understood when it fit on the data. So you can see that I am using the function on income category, educational level, marital status. So here you can see that the income category had 1, 2, 3, like different kinds of categories present, and these are now converted into integers. And in the way that 120k plus is defined by 0, 40 to 60k is defined by 1, and so on, right? So you can see that so iteration flag and gender were already swapped by integers, and you can see the education level, marital status, income category all has converted into numbers. Next is the describe function. Now describe function is basically a function which creates a table which has statistical data about your data set. You can see the count, meaning the number of data points present, mean for each of the columns, standard deviation, minimum value, maximum value, and quartiles. Right. So the reason why I've used this function is to understand that sometimes it might happen that there are some columns which have very large ranges as compared to others. You can see the, let's go for, yeah, credit limit. Now credit limit has a value or has a minimum value of 1400 and a maximum value of 34,000 as compared to, let's go back, customer age, which has a minimum of 26 and maximum of 73. The ranges are too different, right? So sometimes what we have to do is actually standardize our data before we input it into the model, or else your model actually starts to deviate and the accuracy for the model decreases. So I'm dropping the client number and card category, right? Again, because this is what we have to predict and this is of no use to us. Next, I'm using PCA. Now, PCA is Principal Component Analysis, a package which helps in reduction of your dimensions inside your data, or which is also known as dimensionality reduction, right? So it takes the parameter n components, which is to signify how many rows, sorry, how many columns should be present inside the new transformed data set. So I've taken two values, one is for 7, one is for 10. Again, I've transformed those data, which means that now the shape is changed from 19 to 7 and 10 respectively. So next thing, I'm using the train test split function to categorize my data as training set and testing set, using the random forest classifier, having the estimators as 300 and n jobs is equal to -1. This is telling me how much of branching is to be done, and this is telling me that all of the processors inside your computer are to be used for training the data. Training the model. Then I'm fit the model on the training data. I've used the predict function to predict the testing data. Then I'm taking the accuracy for training, which is 100%. Now I'm taking the accuracy for testing for the test data, and I get a value of 95.41%, which is very high and good. So we can directly use this model. One thing to note again is that I have taken PCA fit 2, right? So PCA fit 2 actually has 10 components, meaning 10 rows, columns. So if you change the value from PCA2 to PCA PCF fit, right? PCF fit 2 to PCF fit, then you might see that there is a reduction in accuracy. And this is because while you're trying to reduce down your dimensions for the dataset, there's some loss of function. So there's always a trade-off between how much you want to reduce the size of the data and how much data loss is present, right? Maybe if you have used a component as 15, there might be a higher accuracy in the testing dataset. So it is on you. For some people, even 20, 30 columns are very less because they have high spec computers, right? High spec. So they don't need to reduce the data because the time taken for training and testing is very less. But for people who have low spec laptops specifically, they might like PCA because it reduces the data while trying to conserve most of the information that is provided by the dataset. And then they can train the model. Lastly, what I'm doing is just saving my PCA component or PCA model, which helps in reduction of the dimension and the actual model that is predicting, right? Because both of them will be used later on when we are trying to mount the prediction model in the Django web application. So with this, we have completed the first part and we will be moving to the second part of the project, which is developing web application using Django framework. The second part of the project where we are building a Django application, again using the Django framework itself. So this will be a web application. And before moving forward and setting up the code, let me just give you a brief of what Django is. So Django is a Python-based free and open source web framework that follows the model template views architectural system. It is a web framework that has a set of components that helps you to develop websites faster and easier. Now, what do you mean by a model template views architectural system? It is so that Django has provided you with a base project on which you can add or append other functionalities which you want on your website. So for that, three most important aspects in Django are to work upon models which stores the tables, the SQL tables, right, where data is stored or retrieved from. Then the views, where most of the heavy work in the backend is done, and the templates, which represents the front end part, especially the HTML files and the static files, which includes CSS, JavaScript, right? So moving forward, first what you have to do is create a project directory inside which you're going to keep the code. Next, you have to build an environment for the project. Now, if you're using PyCharm, like myself, what you can do is click on Files, then Settings. Inside Settings, there's going to be a project and the name of the project directory. For me, I've kept it as bank cards. There would be a project interpreter. Click on this. Then, if you already have an environment set up, that would be shown here. If not, you can click here and click on Add. Then you can create a new environment for this particular project directory. And you can choose the Python version. Since I have both Python 7, 3.7 and actually I have 3.7, 3.8 and 3.6. So I can choose any one of them which I want. For this I have chosen 3.7. Then you can click on OK there and it will create a new environment for you, right? So once you have done that, what you have to do is go into the command line and go inside the my site directory, right? So I'm talking about this directory here, this one. Oops, sorry. Yeah, it's confusing. I'm talking about this one, the first my site directory, where all the runtime requirement.txt proc file are present. So once you go inside that directory, you have to run the command pip install -r requirements.txt. So it will download or install all the requirements that are the packages required by this project to run. So it is going to install all the packages, then you can use those packages. Once you have, or once the this command has been completed, all the packages are now installed. Again, go to the command line and type in python manage.py migrate. So once you type this, all the tables that are required by the Django project itself are going to be instantiated, and maybe the data that is required by Django to run the base project will be stored inside the or inside those tables that just now got instantiated, right? So this is the last code that you have to run, or the last command that you have to run. But before that, let's understand how the or how this project is actually working. So as I told you before, that there's a template model views architectural system, right? So the template is this. So this is the HTML file we have. You can see the CSS here. This is install or internal CSS, and right, internal CSS. And this is, now you can see the forms. So what we are doing is we are creating a form from where a user might input the data, and then that data is going to be submitted to the backend, right? So we have a form which has different kinds of inputs to be filled, and then you can see at the bottom here that there is a submit button, and once you click on that, then all of the above information is going to be submitted to the backend. Now this views is the backend part, right? And this views is present actually inside polls. So what I've done is I got a basic setup that was given to me by Django, which had only my site. This is the project folder, and then this is the app folder. So what you have to do is you create different apps which includes all the functionalities that you might want on your website. So likewise, I created an app which has a functionality of storing this data, then using this data to predict and then return that predicted value back to the front end. So here you can see that all of the data that was submitted through the template, that was my index.html file, is now sent to the backend inside the views and is stored in different, you can see the different variables, right? A lot of different variables are now filled up with that value, and then that those variables are actually used to create a data frame, fill the data frame. So here you can see a data frame is created with all the columns, and then the data frame is filled with all the values. Lastly, you can see that I'm calling out the PCA model, right? So this PCA model is going to shrink down the data into 7 or 10 columns, right? Whatever PCA model we are using, then that shrink down data is going to be set into the loaded model, right? So this loaded model is actually loading the random forest classifier model, and then using the predict function, I am predicting the result. If it would be a blue or a gold or a platinum or a silver card, right? So first loaded the PCA model, transformed the data, loaded the random forest classifier model, loaded that model, predicted through that loaded model, and lastly what I'm doing is, with the help of context, I'm returning the predicted value here. So you can see that this function has a lot of things going on inside, and lastly it has a render function which is being returned. So from this, what happens is that inside your views, different functions are defined which are mapped to a template, right? Here you can see it is mapped to the index.html template. Then what happens is that once this function is called, it renders the index.html page, it gets the data from there, manipulates the data, or maybe finds results from the data and sends back the result to that page itself. But you can see that there is no call out for this function, right? It is only defined here. So you can see the urls.py, right? URLs page is inside the polls only, and here you can see a path is defined. So this path is actually the URL on which this index function will be called. So once we go on to that path, this index function will be called automatically, and the views will understand that the index function is called. So I have to render the index.html page, and then all the data and manipulation handling, all of that stuff is done later on, right? So this is how the template views function is actually currently in work. We haven't included the model because we are not trying to save the data. Just that we get the data, we get the result, we showcase the result. We don't store this data anywhere except in variables, not inside the tables. Right. So last part is the settings. So this is actually present inside your project folder, right? Where settings, URLs, WSGI, and ASGI files are present. So the way your application works is actually coordinated using the settings.py file. You can set up the allowed host on the URLs on where this Django application will work at. Set up debug as equal to true or false. If it is set up to true, then it is for all the errors that your code might have, it is going to showcase that on the site itself. Next, you can see the installed apps, which has authentication, content types, sessions. So as I told you before, Django provides you with a base application which already handles the maybe sessions, static files, authentications, right? You don't have to create an application from scratch. Now, but if you want to append something new, some new functionality, then you have to specify that, and we build apps specifically for that only. So later on, when you have built your app, you have to specify that app here also. It also takes care of security, right? There is not going to be any vulnerability unless you have created one yourself. The base Django project already handles the security, the session, right, the CSRF tokens, and like so. Next, you can see the database. If you want to connect a database with your application, you can set them here. You can connect different databases to one application also. For that, this databases is present here. Since we haven't connected any, so we are just using the SQLite 3 that is pre-provided with the Django application itself once you install the Django application package. Last is setting up the static files. So for that we set up a static URL and a root. So root tells you that there's going to be a folder present where all the static files are to be stored, and to access those static files you have to use the static URL. So this is pretty much important when we are going for production, right? And with this, I can say that we have completed understanding the second part, that was the Django application, how to set it up, how to make it work, and how it actually works with the model template views architectural system. Now I might shuffle them up, but you get the gist, right? With this, what I want to show is the last command, that was python manage.py run server. So if I type in this, it starts the server locally, right? The development server is started on your machine itself, and it provides you with the localhost URL. So you can see that a localhost URL is present here. Once you click on that, your website will be loaded. So you can see a website is loaded with a lot of questions here. You can just type in or select the option, and last you click on submit. So once you click on that, your prediction will be done, right? So with this, we have completed the second part, that was the Django application, and we move on to the third part, that is the deployment on Heroku project, where we will be deploying our web application on Heroku. So before we start with Heroku, we have to use some files which are like commands for Heroku to understand. Let's start off with runtime.txt and proc file. So runtime.txt is basically just telling Heroku which language or base is to be used by the server. As you can see, Python is to be used and the version 3.7.10 is going to be used. Next is proc file. So proc file is the mechanism for declaring what commands are to be run by your application in Heroku platform. The commands that are specified in the last part of the project, like the run server or the migrate, these commands are actually executed in Heroku's server using the proc file, so that they are able to set the code properly and run the application on their server. So once you have done that, you can just upload the code, right? Upload this code to GitHub. As you can see, I've uploaded the code onto the repository named card request prediction, and you can see that the code is uploaded here with my site polls and then flow proc file manage.py, and so the code is to be uploaded in the same exact order and manner, because if you change the order or maybe create other folders, then it creates problem in Heroku. Next, what you have to do is go to Heroku. If you don't have an account, just register yourself into one. It is pretty easy. And once you log in into your account, you would be redirected to your dashboard, which will be listing out all the apps that you have created. So if you want to create a new app, you can click on this new here, create new app. Once you click on that, you will have to type in the app name and the region, then click on create app. Since I've already created an app, I won't be doing this. But once you create the app, it will be showcased here. And for me, this is the app. So once you click on the app, you will see some options like overview, resources, deploy. So first you have to do is go to settings. Inside settings, scroll down to build packs, and in build packs, click on add build pack. Then click on Python and click on save changes. Once you do that, it would show that Heroku is going to use the Python build pack for its server now onto this particular app only. Next, what you have to do is go to deploy. Now in deploy, it is showing that the deployment method, and there are three methods. You're going to choose the middle one, that is GitHub Connect, and you will have to click on that. So it would ask you to log into your GitHub account, and once you do that, this Heroku account will be connected to your GitHub account now. Next, you will be seeing a search bar where you can search the repository you want to connect to this particular app. So you can search here, then it would showcase you the repository name. Click on that. Here there would be a connect button. Click on connect, and then it would show you that connected to your account, your repository by your account, right? Then you have to scroll all the way down to manual deploy and choose the branch in which your code is present. Note my code is actually present in the master branch. So I will click on master, then click on deploy branch. Now, once you have done that, the code is now going to be set up onto the server. This might take a little more time, as you might expect also. So here you can see that a Python app is detected since we are using the Python build pack. Next, you can see that it has detected the version from the runtime.txt. Now it starts to install all the packages that are required by this project, which was specified inside the requirements.txt. Next, you can see a command that is specific to Django is run, that is collect static, which means that now all the static files are going to be separated out from all the apps and are going to be stored inside static files folder only. Next, you can see that it is compressing the files and then it is going to launch your web application onto its server. So once all of this process has been completed, you will be seeing a view button here. And once you click on that, you will be redirected to your application. Now I'm going to wait for the view button to appear. Yeah, as you can see, your app was successfully deployed. And once you click on the view button, you're going to be redirected to your web application. So once you fill in the name, well, I'm not 56. I don't have children, right? Just putting in any, yeah, just putting in anything. And for those who might be taking this seriously, please don't. And telling me that those are some of the numbers that I've just input are actually wrong can't happen. Yeah, I'm just inputting the data. You don't have to be so critical about it. Once you click on submit, the processing is done, and lastly you can see the card requested by customer will be blue. So it has predicted that this customer with this type of information will be trying to request a blue card. So the bank can now directly go to that customer and ask if he or she wants to purchase or to issue a card, and he or she would already know that a blue card is going to be purchased by this customer or issued by this customer. So with this we have completed the third part also, and now our project is completed.